Hi, so in this video we're going to be using trigonometric substitution in order to solve this integral. So we have the integral of 1 over the square root of 4x squared plus 1 with respect to x, and we're going to be using this triangle in order to solve the integral. So on one side of the triangle we can write 1, and on the other side we can write 2x. By using the Pythagorean theorem, the square root c squared equals a squared plus b squared, so we have c squared is equal to 1 squared plus 2x squared. And we can take the square root of that to get the triangle. So we have 1 plus 4x squared is the hypotenuse. So in order to substitute into this integral using trigonometric functions, we can start looking at the triangle to form conclusions. So we have tangent of theta is equal to 2x over 1. So we have tangent of theta is equal to 2x. And if we're going to solve for dx, let's first solve for x. So we have x is equal to 1/2 tangent of theta. And then to get dx, we can take the derivative is equal to 1/2 using the trigonometric identity. Tangent of theta, the derivative of that is secant squared theta with respect to theta. So now we can take another trigonometric function on the triangle to solve for the square root of 4x squared plus 1. So we can see that secant of theta is equal to the square root of 4x squared plus 1. So now that we have these identities on the right, we can start substituting into the integral. So let me rewrite the integral. So we have the integral, and we solve for dx right here. So dx is equal to 1/2 secant squared theta d theta. So I'm just going to take out the 1/2. And we have secant squared theta d theta. And then we solve for the square root of 4x squared plus 1, which is equal to secant of theta. So now from here we can simplify. So we have 1/2 the integral, and then secant squared theta divided by secant of theta is going to be equal to secant of theta with respect to theta. So now we can just take the integral from here. So we have 1/2, and then the integral of secant of theta is the natural log of the absolute value of secant of theta plus tangent theta. And don't forget plus c. So now we have these trigonometric functions, but we have to substitute in from the triangle. So this is going to be equal to 1/2 the natural log. And we see that we already have defined on the right secant of theta is equal to the square root of 4x squared plus 1. And then we have tangent of theta, which we already solved, is equal to 2x. And then don't forget the plus c. So that's the answer.